Today we're going to be explaining parametric uses in real life, taking up this 2D example of U standing at 0.50, a terrorist standing at -50, and an airport standing at 6,0. The terrorist is launching a missile at -50, the point he's standing at, in this parabola shape, passing through 0,5 and hitting the airport at 6,0. But you, standing at 0.50 and being the expert in missile launches and parabola shapes, and as an expert in parameterized equations, need to figure out a parabola that will pass through the hit point along with your point, and should you miss the missile, retaliate by hitting the terrorist at -50. So how are we supposed to find out these two parabolas and consequently save the airport? Well, in order to do this and maintain the two missiles' direction and maintain your expertise as true, we must employ the usage of parameterized equations, and more specifically, parameterized parabolas. We can first, by helping us out, we can find out the terrorist's parabola, the parabola in red, where it's going to pass through the points -50, 60, and 0,5. And we can plug that into the intercept form for a parabola, which is y is equal to a multiplied by x minus h multiplied by x minus k, with points h, 0 and k, 0 being the x-intercepts. We are given the two x-intercepts as 50 and -50, as you can see, or 60, as that's the airport point. So it should be x plus 6 multiplied by x, that should be minus, that's positive 6, not negative 6. X minus 6 multiplied by x plus 5. Now we must figure out the a variable in order to get our parabola, and we also know its hit point, the point that's also passing, its y-intercept. So when y is equal to 5, x should be 0. Therefore we get 5 is equal to a multiplied by -6 multiplied by 5, which we can rewrite as a is equal to -5/30, which can be simplified into -1/6, which we can then reapply back into our equation to get the terrorist's parabola, which is y is equal to -1/6 multiplied by x minus 5, or x plus 5, multiplied by x minus 6, which if we factor out, we can get its general equation, and with its general equation, find out its parametric equation and maintain the missile's direction along with its time and speed. So this will become x squared minus x minus 30, which we can then plug -1/6 into the function to get -1/6x squared plus 1/6x plus 5. And here we have the terrorist missile function, which is this parabola right here. But this parabola does not have a direction. Furthermore, it does not have a speed, nor does it have a restriction. The restriction that we want, that is between -50 and 6,0. Therefore, in order to maintain these two attributes of our problem, we must employ the usage of a parameter, which we're going to be defining as variable t defined to variable x within the equation. Therefore, we can rewrite this function within its parameterized form as y is equal to -1/6x, or the x will now become t representing time, plus 1/6t plus 5, which this equation, with t's range being between -6, the airport, and this will be +6, and -5, the terrorist, we will have the parameterized equation of our missile. But this missile has a problem, and it's the t's restriction. Time cannot start at a negative value. It has to start at 0. Therefore, we must change this parameterized range to be between +11 and 0, meaning that the time will start at 0 and end at 11 seconds. In other words, it will start at the terrorist point, travel for 11 seconds to reach the airport point at 6,0. So we have to rewrite this as -1/6 multiplied by t minus 5 squared plus 1/6t minus 5 plus 5. And this parameterized equation will give us the missile that will travel 11 seconds from point -50 to 6,0 and potentially destroy the airport. And we can know it starts at the terrorist by applying t's range. We know t starts at 0, so when t is plugged into the y, or the function, we will get -50 as our output. Therefore, we can safely be sure that this parameterized equation right here will give us the terrorist missile along with maintaining its direction in this clockwise fashion as these arrows represent. But it's important to know that this will take 11 seconds. And as terrorists are deceitful, this terrorist is especially deceitful. He knows that you're going to be launching your missile at the same time he's launching his. And therefore, he wants to ensure to make his missile faster than yours in order to hit the airport faster and hence dodge your missile. You have an insight of this and you know that he's going to reach 05 in 4 seconds. In 4 seconds. And this is going to be the unit of t in this problem. But in the original function for the terrorist, this function will not take 4 seconds. As we know, from 6 to -5 will take us 11 seconds for the terrorist to hit our missile. Or to hit the airport at least. Therefore, we must change the terrorist's parabola to be t is between 4 now instead of 11, as the original function will give us the original function would actually give us 11 seconds of travel time, whereas this function will give us 4 seconds of travel time. Therefore, we must rewrite this function as y is equal to -1/6 multiplied by 11/4 t plus 5 or minus 5 squared plus 1/6 multiplied by 11/4 t minus 5 or plus 5. Hold on, this should be plus 5. Yeah, it's supposed to be minus 5 and plus 5, which this should be a minus sign, not a plus sign. Please excuse me for that. And this parabola will give us a missile that will be traveling from the terrorist and hitting the airport in 4 seconds, along with maintaining its direction and starting from point -50 traveling to 6, 0. And we can be sure that this is so by applying t's range within this function. The reason why we added 11/4 to be t's new coefficient is because this missile is traveling 11/4 times faster than 11 seconds previously. Therefore, this missile will be traveling quicker and faster, and as a result more deadly, where when t is equal to 0 we can plug the lowest value into it to find its starting point, which will give us -50, the point the terrorist is at. So now we have found out the terrorist missile. Now we must find out our missile. Therefore, we must employ the usage of a parameter into our parabola as well. Our parabola will pass through the points -50, 05, and 5, 0. Therefore, we must write this and plug it into the intercept formula for a parabola, which is y is equal to x minus h multiplied by x minus k multiplied by a. We are given the two x-intercepts as -50 and 50. Therefore, rewriting this as 8 multiplied by x minus 5 multiplied by x plus 5, which we're also given is y-intercept of 0,5. So when y is equal to 5, x is equal to 0, this will be -5 multiplied by +5, a rewritten as -5 over 25, which can be simplified into -1/5. There we go. Now we have our parabola. Y is equal to -1/5 multiplied by x squared plus or minus 25. This is a perfect square, therefore we can rewrite it as x squared minus 25, which can be simplified by plugging in -1/5 into the equation to get -1/5 x squared plus 5. And there we have the parabola for our missile. But then again, same thing with the terrorist missile. This missile will not maintain a direction. Therefore, we must give it one by giving it a parameter defined by t to variable x, likewise to the terrorist, which can be rewritten as y is equal to -1/5 multiplied by t, should be t squared plus 5, with t's range being between the airport or your point 5 and -5. But time cannot start at a negative value. Time must start at 0. Therefore, we must rewrite t's range to be between 10 and 0 by adding 5 on both sides, giving us the new function of y is equal to -1/5 multiplied by parentheses t minus 5 squared plus 5. And this parabola will give us our missile function. But this missile will be too slow to intercept the missile in time, as this missile will travel at 10 seconds. And as we know, 10 seconds is greater than 4 seconds. We will not save the airport with this function. Therefore, we must increase the speed of the missile by changing t's parameter or range by being between 4 and 0, the same time it's going to take the terrorist missile to hit the airport. Therefore, we can rewrite this equation as y is equal to negative 1 over 5 multiplied by, parentheses, 4t, or it should be 10 over 4t, 10 over 4t minus 5 squared plus 5, which we have 10 divided by 4 as t's new coefficient, as this missile will be traveling 10 over 4 times faster than the previous function of 10 seconds, with t's range being between 4 and 0. And therefore, we have found out the missile needed to save our airport. Right here, y is equal to negative 5, 1 over 5 multiplied by 10 over 4 is going to be simplified into 5 over 2, t minus 5 squared plus 5. This missile, launched at the same time the terrorist launches his, will save our airport and intercept it exactly in 4 seconds at the point 05. And there we have an example of the usage of problematized equations in real-life scenarios.